Welcome to the next video in our series, Exploring Cimatron for Mold Design. As always, we wish to thank you for your interest shown in Cimatron, and we encourage you to view the rest of the movies in this series as well. This video will focus on separating cavity and core faces by using quick split, creating simple shutoffs, parting lines and parting faces, and we're also going to work with a multi-cavity situation involving standard mold bases from catalogs. We will begin by looking at quick split to find the mold pull directions. Here we will pick the appropriate name for the pull direction and then pick a face that we know lies in that pull direction. Once calculated, the slide bar can be used to dynamically separate the mold splits. And with that, we will now do the same thing on the core side. Quick Split will now look at the remaining faces, and those faces that it sees in that direction will be assigned to the core. As we rotate the part around, we find that there is an area that's left in gray. This area is trapped or undercut. This area would be made by a slide, so we will give it its own pull direction. Even then, faces are still left behind in gray, which means that they are undercut as seen from that pull direction. We will simply attach these faces and other faces that we want to have on the slide. Here we can see the draft angle analysis as it measures the draft angles in each pull direction. Individual features can be tagged to show if they're undercut or straight, and this information can then be published to a PDF file. By default, areas shown in red are undercut, and areas in purple have no draft. Now we'll work with parting lines, parting surfaces, and shutoffs. To do that, we're going to create what's called a parting surface part. And this will serve as a part file for all our shutoffs and parting faces. At this point, we will display and work with just the cavity faces. We'll now look at a function that helps us to find all the internal shutoffs and fill them in one operation. Cap internal islands will do more than create simple single-face shutoffs, but in some cases we'll find even more complicated multi-face areas and close those as well. The options allow for the situation if that shutoff face is not created, but it will leave behind the parting line, which other faces could be created from. We will now use a composite curve to create an outer parting line. The options allow for automatically chaining along open edges or even across geometry where there may be some gaps. Now we will create a 1-inch shutoff around the part by using extend parting. Each pink vector is a control point for driving a tangent extension around the part. The result is a nice, clean, tangent shutoff. From here, we go back into Quick Split, and we use parting attributes to assign the knowledge to these new faces that they're shutoffs between cavity and core. We simply pick the faces, and then pick the cavity and core Quick Split faces. Now we can see the shutoffs included in the dynamic separation. As we said at the beginning, this is a two-cavity layout. So from here, we're going to mirror the part that we've separated with Quick Split, as well as the parting faces that we have created. First, we will create a mirror plane at the tool center. Then we will mirror the part across the middle plane. We could just as easily copy and rotate the part for a two-cavity mold. In this case, we're going to mirror the part so it'll be a left-hand, right-hand mold. Likewise, the part could be copied to numerous locations to show multi-cavity situations. In a previous video, we discussed using layout part for multi-cavity situations. So if, say, this were to be a four-cavity, we would have used a four-cavity layout when we started with the Mold Wizard. Using QuickSplit, we can see that all the attributes remain assigned to those copied faces. We can now build the runout or remaining parting faces, and through this you'll see a number of different techniques in use. In the center area, we will use Blend to create these simple ruled faces. Another nice technique is to use Spline to create a tangent-to-tangent curve between two faces. And then we can use this spline in the construction of parting line faces as well. Next, we will use Composite Curve to automatically chain the spline and the outer edges of the faces. From here, we will use Bounded Face, which will create as flat as possible a parting surface inside that composite curve. This same technique will be used again this time toward the front of the mold. As you can see, Cimatron Surfacing offers a number of automatic surfacing tools, as well as powerful tools where more control is needed. Now we're going to automatically chain around the outer edges using Composite Curve. And now we will use External Parting Surface to create the outside parting faces. Now back to QuickSplit one more time to see the cavity and core separation and to see that all these parting surfaces have had attributes automatically assigned to them. What you've seen just barely skims the surface for all the functionality available in creating parting surfaces. Let's look at the standard catalog mold bases in Cimatron Mold Design. In the Mold Wizard, we will find many of the more popular catalog mold bases. Each catalog is unique to that specific vendor. Once the mold base has been selected, margins can be established to determine overall steel size, different plate thicknesses, the ejector stroke, and then from there, the wizard will recommend the closest mold base size found in that catalog. The mold base size is now shown in preview. From the pull-down, the mold base size can be selected at any time. And clearance values can be placed on the A and B plate to create a gap at parting line for cavity preload. The next window of the wizard is for establishing the individual plate thicknesses. Each plate has its own individual pull down for selecting the thickness. The sizes available are those unique to the vendor's catalog. The components to be ordered with the mold base can be selected, as well as customized locations. With that, the mold base is now created as a full assembly. The sub-assemblies of the mold now show in the tree, and each component is now listed in their appropriate sub-assembly. Thank you for reviewing this presentation. Look for our next presentation to follow, which will be talking about cutting the A and B plate and also building a slide assembly.